Okay, students, let's get started with AS Level Physics, October November 2025, Paper 2, Variant 4. This is 1 hour 15 minutes ka paper. This is your AS Physics ka paper. Now, let's start with this. A child kicks a ball so that it leaves the horizontal ground with a speed of 28 meters per second at an angle of 34 degrees to the horizontal as shown in figure 1.1. भाई एक चाइल्ड है जो कि बॉल को किक कर रहा है एट एन एंगल ऑफ 34 डिग्रीज एट अ वेलोसिटी ऑफ 28 मीटर पर सेकेंड एयर रेजिस्टेंस इज निग्लेजिबल बेटा अगर एयर रेजिस्टेंस निग्लेजिबल होगी व्हाट डज दिस मीन इफ योर एयर रेजिस्टेंस इज निग्लेजिबल your acceleration is 9.81 meters per second square acting downward. The ball leaves the ground at time t is equals to 0. Okay. Calculate the horizontal component and the vertical component of the velocity immediately after it has left the ground. So you have to calculate the horizontal and vertical components. Sir, how are we going to do this? Very, very easy. Let's say this is your velocity of 28. What we can do is we can consider a right angle triangle. बेटा हम एक right angle triangle consider कर सकते हैं. This is your vertical component and this thing is your horizontal component. This is a 90-degree angle. How will you calculate the horizontal component? This is your base. This is your hypotenuse. How will you calculate the horizontal component? Genius is, you will say cosine 34 is equals to base over hypotenuse. Hypotenuse क्या है बेटा 28? 28 cosine 34 is equals to your base, or you can say this is your horizontal component. What will your horizontal component come out to be? 28 cosine 34. This comes out to be 23.2. बेटा horizontal component of velocity क्या आ गई 23.2 meters per second is your horizontal velocity. Simple. You can place this on the bottom side यहाँ पे. Now how will you calculate the vertical component? हाँ जी vertical component कैसे निकालेंगे? If you realize this is your perpendicular, this is your hypotenuse, you will say sine of 34 is equals to perpendicular divided by hypotenuse, that is 28. 28 sine 34 is your vertical component. Let's calculate that as well. This comes out to be 15.7 meters per second is your vertical component. ठीक है भाई वर्टिकल कंपोनेंट भी आ गया हॉरिजॉन्टल कंपोनेंट भी आ गया सिंपल you can just place in the values here 15.7 and 23.2. Simple, nothing complicated here, very easy. Now let's further move ahead. Show that the ball reaches its maximum height at time t is equals to 1.6 seconds. बेटा हमने शो करना है कि बॉल रीच कर रही है मैक्सिमम हाइट एट टी इज इक्वल टू 1.6 सेकेंड. Always remember at maximum height your vertical velocity is 0. बेटा always remember कि at the maximum height your vertical velocity is 0. Your vertical velocity becomes 0 at the maximum height. Now, no. Just focus. You can say that the upward vectors are positive, downward vectors are negative. Your initial vertical velocity is what? Beta initial vertical velocity is 15.7 meters per second. Final vertical velocity is 0 meters per second. Perfect. Where is your acceleration acting? Acceleration is 9.81 meters per second square acting downward. So acceleration will become what? Negative 9.81 meters per second square. Sir, why have you taken acceleration as negative? This is a very commonly occurring thing. Sir, why have you taken acceleration as negative? Because I have taken the downward vectors as negative, upward vectors as positive. Acceleration is acting downward. That's why I have taken it as negative 9.81 meters per second square. Can you calculate the time? Time निकाल सकते हो बेटा? Yes. You will say V is equals to U plus AT. Final velocity is 0. Initial velocity 15.7 plus negative 9.81 into time t. Bring it to the other side. 9.81 into t is equals to 15.7. Time comes out to be 15.7 divided by 9.81. What does your time comes out to be? Let's calculate that. The time comes out to be 1.596 seconds. That is equals to 1.6 seconds. Correct to two significant figures. Let's further move ahead. On figure 1.2, sketch the variation of horizontal velocity with time between time t is equals to 0 till time t is equals to 3.2 seconds. Label your line with capital H. Always remember, always remember, horizontal velocity remains constant throughout projectile motion. Beta, horizontal velocity remains constant throughout projectile motion. What is your horizontal velocity? हाँ जी, horizontal velocity क्या है? 23.2. ये constant रहेगी throughout the projectile motion. Throughout the projectile motion, you will have a constant velocity of 23.2. Now, this is 20. You are going from 20 to 30. You are covering 10 units. बेटा आप 10 units cover कर रहे हो in 5 boxes. One box is equals to how many units? 2 units. This will become 22. 23.2 lies somewhere here. You draw a straight horizontal line like this. Label this as capital H. Always remember this key point. Please write down this key point. Horizontal velocity remains horizontal velocity remains same throughout projectile motion. Simple. Nothing complicated. Here, आगे बढ़ते हैं. On figure 1.2, sketch the variation of vertical velocity with time between time t is equals to 0 and 3.2 seconds. Assume that the velocity in the upward direction is positive. Label your line with capital V. अच्छा बेटा देखो करना क्या है. Now you have to draw the graph for the vertical velocity. You have to assume upward direction as positive. आपने upward direction को positive लेना है. You have to assume the upward direction as positive. ठीक है. And you have to draw a graph for vertical velocity. How will you do that? Okay. What is your initial vertical velocity? 15.7. Okay. Initial vertical velocity beta क्या है? 15.7. So initially, let's say you have a vertical velocity of 15.7 here. Your vertical velocity becomes 0 at the maximum height. And maximum height कब reach कर रहे हो? 1.6 seconds पे. Okay. And your velocity becomes negative 15.7 at 3.2 seconds. Somewhere here. So you have these 3 points. Can you connect the dots? Yes, sir. Can you connect the dots like this? Yep, this is your line. Let's label this line as V. बेटा हमने क्या किया? कैन यू रियलाइज? हमने मार्क किया अपवर्ड वेलोसिटी एज पॉजिटिव 15.7. The vertical velocity becomes 0 at maximum height of 1.6, and the vertical velocity is negative 15.7 at 3.2 seconds. Simple. You draw a line like this. Lastly, you have to remember, sir, why is this a downward sloping line? Beta, ये downward sloping line क्यों है? Can you realize? Do you remember this key point? Gradient of velocity time graph is equals to acceleration. Can you realize your acceleration is negative 9.81 throughout? That means आपकी acceleration negative and constant है throughout the journey. If your acceleration is negative and constant throughout the journey, that means your gradient of velocity time graph will be negative and constant throughout the journey. You will draw a downward sloping line. Simple. The total change in momentum of the ball between leaving the ground at time t is equals to 0 and landing on the ground at time t is equals to 3.2 seconds is 13 kg meter per second. Define momentum. What is the definition of momentum? Genius says, what is the definition of momentum? बेटा momentum की definition क्या है? Product of mass and velocity is your definition of momentum. Product of mass and velocity. Simple. Calculate the force that acts on the ball in the air. How will we calculate the force that acts on the ball in the air? Change in momentum over change in time. Okay, so how will you calculate the force that acts on the ball? Very, very easy. Force is equals to change in momentum over change in time. Beta, change in momentum क्या है? 13. What is your change in time? 3.2. Can you calculate the force? Force निकाल सकते हो? Yes, very easy. 13 divided by 3.2. The force comes out to be 4.1 Newton. Easy peasy. Let's move ahead. आगे बढ़ते हैं बेटा. Now, determine the mass of the ball. Now you have to determine the mass of the ball. How will you do that? कैसे करोगे? You first of all know, you first of all know that your change in momentum is 13. Beta, how can you write change in momentum? Mass into change in velocity is equals to 13. You have to calculate the mass. Mass is equals to 13 divided by the change in velocity. Now, how will you write change in velocity? Final velocity minus initial velocity. Beta, can you realize your final velocity, final vertical velocity? This final vertical velocity is negative 15. Your initial vertical velocity is positive 15. So, what will you say? 13 divided by negative 15.7 minus 15.7. What does your mass comes out to be? 13 divided by, yes, your mass comes out to be negative 0.41 kg. You will ignore the negative sign. आप नेगेटिव साइन को इग्नोर कर दोगे. Your answer for mass comes out to be 0.41 kg. Always remember, mass can never be negative. Ignore the negative sign. You get your answer as 0.41 kg. Simple. आगे बढ़ते हैं. Figure 2.1 shows a square metal sheet of non-uniform density. Okay. So you have a metal sheet of non-uniform density. Sir, what does non-uniform density means? This means that weight doesn't act in the middle. इसका मतलब ये है कि weight middle में act नहीं कर रहा. with a thin wooden rod fixed at its center. One of the corner of the sheet is labeled X. अच्छा जी एक corner of the sheet is labeled X. Okay. The rod has negligible mass. The mass of the metal sheet is 2.8 kg. अच्छा जी metal sheet का mass क्या है भाई? 2.8 kg. Perfect. The rod is supported so that the rod is horizontal and the metal sheet is vertical. Metal sheet vertical है, rod is horizontal. Define the torque of a couple. बेटा torque of a couple की क्या definition है? Product of force and the perpendicular distance between the two forces. You will say product of force and the perpendicular distance, perpendicular product of force and the perpendicular distance between the two forces. Simple. आगे बढ़ते हैं बेटा क्या लिखा हुआ है? When the rod is supported in such a way that it can rotate freely within its supports, the sheet hangs in equilibrium with point X vertically above the rod. Point X क्या है? Vertically above the rod as shown in figure 2.2. Perfect. On figure 2.2, draw a line to indicate the range of possible positions for the center of gravity of the metal sheet. बेटा हमने बताना है कि सेंटर ऑफ ग्रेविटी ऑफ मेटल शीट कहाँ कहाँ लाई कर सकती है. वेयर कैन द सेंटर ऑफ ग्रेविटी ऑफ द मेटल शीट लाई? नाउ यू हैव टू रियलाइज वन थिंग. द शीट हैंग्स इन इक्विलिब्रियम. बेटा हमारी शीट इक्विलिब्रियम में हैंग कर रही है. Whenever you are in equilibrium, write down a key point. Objects in equilibrium or objects in stable equilibrium have a center of gravity below the pivot slash support. बेटा आपका जो भी ऑब्जेक्ट स्टेबल इक्विलिब्रियम में होगा, it will have a center of gravity below the support. So here you can draw a line like this. आप बिलो द सपोर्ट कहीं भी सेंटर ऑफ ग्रेविटी को लाई करा सकते हो, बिकॉज फॉर अ स्टेबल इक्विलिब्रियम और फॉर इक्विलिब्रियम वाले ऑब्जेक्ट्स सेंटर ऑफ ग्रेविटी लाइज below the support, below the pivot, whatever you want to say. Let's further move ahead. When a torque of 3.3 Newton is applied to the rod, the sheet is held in equilibrium with two of its edges horizontal as shown in figure 2.3. Point X is at the top left corner. अच्छा जी यहाँ पे point X आया हुआ है, ठीक है. Explain whether the torque applied to the rod to hold the sheet in equilibrium is clockwise or anti-clockwise. बेटा हम एक टॉर्क अप्लाई कर रहे हैं ऑफ 3.3 न्यूटन टू कीप द मेटल शीट इन दिस पोजिशन. You have to tell whether this torque will be anti-clockwise or clockwise. Now, if you focus थोड़ा सा, अगर आप थोड़ा सा फोकस करें, तो what is happening? अच्छा, let me do one thing. I think you will understand it much better if I do one thing. Let me replicate the shape. Let me replicate the shape. I'm about to do one very important trick here. अच्छा जी, हमने ये शेप रेप्लिकेट कर दिया. दिस इज एक्स and this is your line. Now what we have done is we have rotated it like this. बेटा हमने शेप को रोटेट कर दिया है like this. Can you identify in which portion does the center of gravity now lies? बेटा सेंटर ऑफ ग्रेविटी कहीं यहां पे लाई करेगी on this dotted line. Now the center of gravity lies somewhere on this dotted line. Let's suppose center of gravity is lying here. तो बेटा वेट यहां से डाउनवर्ड एक्ट करेगा. If the center of gravity is lying here, the weight will act downward from here. This will cause the entire sheet to rotate in the clockwise direction. बेटा ये पूरी की पूरी शीट को clockwise direction में rotate कर देगा. The weight of the sheet will cause the sheet to rotate in clockwise direction. Hence, to keep the sheet in equilibrium, you need a torque in the anti-clockwise direction. देखो वापस से समझ लो. फर्स्ट ऑफ ऑल हमने क्या किया, हमने यहाँ पे आइडेंटिफाई कर लिया कि इफ़ योर ऑब्जेक्ट इज इन इक्विलिब्रियम योर सेंटर ऑफ ग्रेविटी विल लाई बिलो द सपोर्ट. फिर हमने एक सेम शेप बनाया और रोटेट किया. इफ यू सी द सेंटर ऑफ ग्रेविटी इज लाइंग ऑन दिस डॉटेड लाइन. If center of gravity is lying on this dotted line, the weight will act somewhere on this line. बेटा अगर weight somewhere on this line act करेगा तो it will cause a clockwise movement. Now, if the weight causes a clockwise movement and you want to keep the steel sheet in equilibrium, बेटा देखो weight की वजह से clockwise movement generate हो रहा है. If you want to keep the sheet in equilibrium, you will have to apply an anti-clockwise torque. तो टोटल क्या लिखोगे? व्हाट विल बी योर आंसर इन टोटलिटी? व्हाट शुड योर आंसर बी? क्या कहोगे यहाँ पे? यू विल से द वेट ऑफ द शीट is in the clockwise direction. You will say moment of weight of sheet about the rod. Moment of weight of sheet about the rod is in clockwise direction. Hence, the torque will be in the anti-clockwise direction. Simple. Nothing complicated here. आगे बढ़ते हैं. Show that the center of gravity of the sheet has a horizontal displacement of 1.2 meter from the rod. अच्छा जी, हमने शो करना है कि the center of gravity has a horizontal displacement of 1.2 meter from the rod. बेटा द सेंटर ऑफ ग्रेविटी पे जो वेट लग रहा है this has a horizontal displacement of 0.12 meter from the rod. We have to show that. तो हम क्या कहेंगे? The moment generated by the center of gravity or by the weight is equals to what? 3.3. बेटा the moment generated by the weight is 3.3 Newton meter. इस मोमेंट की जगह क्या रख देंगे? फोर्स इनटू द डिस्टेंस x that we want to prove. 3.3. अच्छा फोर्स किस तरह निकालेंगे? व्हाट वाज योर वेट? वेट गिवन था नहीं. यू वर गिवन द मास 2.8 kg. कैन यू कैलकुलेट द वेट? 2.8 into 9.81 into d is equals to 3.3. Can you calculate the distance, horizontal distance of the center of gravity from the rod? Can you do that? 3.3 divided by what? 2.8 into 9.81. What does your answer comes out to be? हाँ जी, योर आंसर कम्स आउट टू बी 0.12। तो बेटा हमने क्या कहा, द मोमेंट क्रिएटेड बाय द वेट इज इक्वल टू व्हाट, 3.3। मोमेंट इज इक्वल टू फोर्स इनटू डिस्टेंस। फोर्स किसके इक्वल हो जाएगी, वेट। वेट मल्टीप्लाइड बाय डी, डिवाइड कर दो, यू गेट योर आंसर ऑफ डी, दैट इज 0.12। The square sheet has an average density of this, uniform thickness of this. Show that the side length of the sheet is this. Okay, easy. You will say mass is equals to density into volume. Beta mass क्या है 2.8, density क्या है 3000. Can you calculate the volume? 2.8 divided by 3000, बताओ वॉल्यूम किसके इक्वल आ जाएगा। हाँ जी, वॉल्यूम इज इक्वल टू व्हाट, 9.310 is the power of minus 4 is equals to your volume. Now you have a thickness of what? 4 millimeter. You have to calculate the side length. कैसे निकालेंगे साइड लेंथ, यहाँ पे आ जाओ, इधर आ जाओ, इधर आ जाओ, ऊपर आ जाओ। Now if you realize one thing here, ये देखो, this thing, square. What does square means? बेटा स्क्वायर का मतलब होता है कि if this length is x, this length will also be x. So you can say the volume is equals to what? 9.3 into 10 raised to the power of minus 4 is equals to x length into breadth multiplied by, oh, these x's look similar. What we can do is let's make them different. X into, yeah, let's do one thing. You can say that the side length is L. यू कैन से द साइड लेंथ इज एल। बेटा अगर एक साइड लेंथ एल है तो दूसरी भी एल ही होगी, वॉल्यूम की जगह एल इंटू एल रख दिया। व्हाट इज योर थिकनेस, 4 मिलीमीटर, 4 इंटू 10 इज द पावर ऑफ माइनस 3। 9.3 10 is the power of minus 4 divided by 4 into 10 is the power of minus 3 is equals to L का square. Can you calculate the answer भाई? हाँ जी, निकाल सकते हो आंसर को। L का स्क्वायर is equals to 0.325 is equals to your L का square. Can you calculate the value of L? Yes. Taken under root 0.2325 is equals to your L. 0.48 meters comes out to be your L. Simple. This is a very calculation heavy paper. Okay. Use the answer in B and the information in C and D to determine the position of the center of gravity. Okay. Of the sheet, indicate the position on figure 2.3 with a point labeled y. Okay, so what do we have to do? Use the answer in B. Okay, where is the answer in B? अच्छा, answer in B हमें ये बता रहा है that the center of gravity will lie below the support. Okay, use the answer in B and the answers in C and D to determine the position of the center of gravity of the sheet of the paper. Indicate this position. Okay, so now you have to indicate the position of the center of gravity. How will you do that? बेटा आपको पता है, let's erase everything. Let's erase everything. You know that the side length, मतलब एक साइड की लेंथ इज 0.48 मीटर्स। ओके बेटा, सो हाउ विल यू मार्क द सेंटर ऑफ ग्रेविटी? फर्स्ट ऑफ ऑल तो आपको ये पता चल गया कि साइड लेंथ क्या है, 0.48 मीटर्स। और ये जो रॉड लगी हुई है, दिस इज एग्जैक्टली इन द सेंटर। सर इसका मतलब क्या है? इसका मतलब ये है कि दिस इज 0.24, दिस इज 0.24। अब हमारी जो लेंथ है या जो हमारी सेंटर ऑफ ग्रेविटी है, द सेंटर ऑफ ग्रेविटी इज लाइंग एट अ डिस्टेंस ऑफ 0.12 मीटर फ्रॉम द rod. So basically what do you have to do? It is lying 0.12 meter from the rod. It is lying somewhere on this dotted diagonal line. आप हाफ वे आ जाओ. Now what do you do? देखो, it's very very simple. What do? You break this line into half. Yeah, you come halfway like this. 0.12 meter. This is your center of gravity. Why? Simple. So what have we done here? पहले हमने identify किया कि side length is 0.48 meters divided into how half. This is 0.24. 0.24 को आपने further divide कर दिया into half. 0.12. This is your center of gravity at position Y here. Simple. Let's zoom out a bit. Let's further move ahead. Okay. A bungee jumper of mass 64 kg. Okay, so let's highlight 64 kg का mass. Secures one end of an elastic rope to a bridge. Okay, ये bridge पे एक rope लगाई हुई है. The other end is attached to the bungee jumper. ठीक है, other end is attached to the bungee jumper. The bungee jumper falls from rest. Okay. If the bungee jumper is falling from rest, initial kinetic energy is zero and descends into the valley below as shown in figure 3.1. Perfect. Figure 3.2 shows the variation of the tension in the rope with the distance h of the bungee jumper below the level of the bridge. अच्छा जी, ये distance h है below the bridge and this is your tension in the bungee jumper की rope. Okay. The rope obeys Hooke's law. State Hooke's law. बेटा Hooke's law क्या कहता है? The rope is obeying Hooke's law. आपने बताना है what does Hooke's law state. What will you say? Hooke's law क्या कहता है? Force is directly proportional to extension. This is what Hooke's law states. Force is directly proportional to extension. This is what Hooke's law states. अब आ गया जो. Determine the unstretched length of the rope. What is the unstretched length? बेटा unstretched length की definition याद है? Unstretched length क्या होती थी? Length of rope when no force is applied. Beta, the length of the rope when no force is applied is your unstretched length. Can you realize कि अगर आपने force नहीं apply की हुई तो this is your length. Sir, how do we calculate this length from 30 to 40? You are covering 20 units. 20 units is equal to 10 boxes. One box is equal to how many units? 2 units. ठीक है. This will become 30, 32, 34, 36. This is 37. The unstretched length is 37 meters. ठीक है. Determine the spring constant. How are you going to determine the spring constant? Calculate the gradient of this graph. You can take this as your first point. इसका first point ले सकते हो. Let me zoom in a bit. If you calculate the gradient of this graph, you will get the spring constant. Let's take this as your first point. X axis में 37, Y axis में 0. And let's take this point as well. X axis में 60. Y axis में what? 500. Can you calculate the gradient? हाँ जी. Can you calculate the gradient? To calculate a spring constant? Yes. इसको नीचे लिख देते हैं. 37,0 and 60,500. Can you calculate the gradient? Yes. Y2 minus Y1. X2 minus X1. Spring constant निकाल लो. 500 divided by 60 minus 37. This comes out to be 21.7 Newton per meter is your answer for the spring constant. Simple. Let's further move ahead. For the position of the bungee jumper at a distance of 120 meter below the bridge, show that the loss of kinetic energy since leaving the bridge is 75 kilojoules. How will you calculate loss of gravitational potential energy? Change in gravitational potential energy is equals to mg change in height. Do we have the mass of the bungee jumper? Yes, 64 kg. 64 into 9.81 into 120. What does the answer comes out to be? Answer comes out to be 75. 10 is the power of 3. That comes out to be 75 kilojoules. Perfect. Show that the elastic potential energy in the rope is 75 kilojoule. Okay. बेटा अब हमने शो करना है कि द इलास्टिक पोटेंशियल एनर्जी इन द रोप इज 75 किलोजूल. सो व्हेन यू आर एट अ डिस्टेंस ऑफ 120 मीटर, बेटा जब आपकी रोप का डिस्टेंस या लेंथ 120 मीटर है, व्हाट इज योर टेंशन? लेट मी सी. द टेंशन इन द रोप इज this. What will this be equal to? You are going from 1500 to 2000. 500 units cover हो रहे हैं. How many boxes? 10 boxes. One box is equals to what? 50 units. This is equals to 1800. So the tension or the force in the rope is 1800 Newton. How will you calculate the extension? बेटा आपकी अनस्ट्रेच लेंथ 37 है, फाइनल लेंथ क्या है? 120. हाउ विल यू कैलकुलेट एक्सटेंशन? एक्सटेंशन किस तरह निकालोगे? 120 माइनस 37, एक्सटेंशन क्या आ गए? यस, दिस कम्स आउट टू बी 83 meters. Can you calculate elastic potential energy? 1 upon 2 Fe. F क्या है भाई? 1800 Newton. This is 83. Can you calculate the answer? Hmm. This comes out to be again 75, 10 raised to the power of 3, 75 kilojoules. Perfect. Yeah, this is also 75 kilojoules. ऊपर वाली भी 75 kilojoules. See what will happen now. Let's see. Explain what can be deduced from the information in C about the speed of the bungee jumper at a distance of 120 meter below the bridge. बेटा कैन यू रियलाइज 120 मीटर बिलो द ब्रिज क्या हो रहा है? आपकी जो भी लॉस इन ग्रेविटेशनल पोटेंशियल एनर्जी थी, दैट हैज बीन कन्वर्टेड इनटू गेन इन इलास्टिक पोटेंशियल एनर्जी. At 120 meters की height, all the loss in gravitational potential energy has been converted into elastic potential energy. So there is no change in kinetic energy. Your kinetic energy becomes zero. Your speed is zero. बेटा आपका बंजी जंपर स्टार्ट रेस से कर रहा था. At 120 meters, there is no change in kinetic energy, hence the kinetic energy still remains zero. Your bungee jumper is at rest at 120 meters. So इसको लिख लो. You can write it here. You can say all the all the gravitational potential energy is converted into kinetic नहीं into elastic potential energy. Hence the change in KE is zero, causing the final KE to be zero and the bungee jumper is at rest. Simple. आगे बढ़ते हैं बेटा। स्टेट द प्रिंसिपल ऑफ सुपरपोजिशन। प्रिंसिपल ऑफ सुपरपोजिशन क्या कहता है? वेन एवर टू और मोर वेव्स ओवरलैप, when two or more waves meet, overlap, the resultant displacement is the sum of individual displacement. So you can say when two or more waves overlap slash meet, the resultant displacement is the sum of individual displacements. Is the sum of individual displacements of the wave. Chalo, let's move ahead. An electromagnetic wave has a wavelength of this. Okay, this is your wavelength. Is incident normally on an aluminum sheet. Okay. The wave reflects at the aluminum sheet and a stationary wave is formed in the region between the transmitter and the sheet. अच्छा जी stationary wave form हो रही है यहाँ पे. Explain how the stationary wave including the nodes and antinodes is formed. बेटा हमने बताना है stationary wave कैसे form होगी. What will you say? The incident and the reflected waves will superimpose. बेटा ये जो आपकी incident waves हैं like this, they will hit, or let me draw it in a better manner. These incident waves will hit the aluminum sheet, get reflected back like this. ये reflect back कर गई. The superposition of reflected and incident waves gives rise to stationary waves. यहाँ पे लिख लो. The superposition, yeah, the incident and the reflected waves superpose the incident and reflected waves superpose to form stationary waves. What further will you write? बेटा आपने एंटी नोड्स और नोड्स के बारे में भी बताना है. What further will you write? If the resultant amplitude is maximum, it results in an antinode. लिख लो. If the resultant amplitude is maximum, it generates an antinode. And if the resultant amplitude is minimum, it generates a node. Perfect. Calculate the frequency of the electromagnetic wave. How will you do that? V is equals to F lambda. Always remember all electromagnetic waves have a speed of 3 into 10 is the power of 8. ये frequency आ गई. Wavelength क्या आ जाएगी बेटा? Wavelength I think was given to you 0.026. 0.026. Can you calculate the frequency? Yes. 3 into 10 is the power of 8 divided by 0.026. Can you calculate the frequency? हाँ जी. निकाल सकते हो. Frequency comes out to be 1.15 10 raised to the power of 10 hertz. This is your frequency. Simple. State the principal region of the electromagnetic spectrum to which this wave belongs. बेटा ये wave कहाँ पे belong करेगी? In the microwave region. Obviously, you will have to remember the electromagnetic spectrum key frequencies. Calculate the distance between a node and an antinode. Always remember the distance between a node and an antinode is equals to 1 over 4 lambda. Do you have the wavelength? I think you have the wavelength. 0.026, ठीक है. Can you calculate this? Antinode से node तक का distance निकाल सकते हो. This comes out to be 6.5, 10 is the power of minus 3 meters. Simple, nothing complicated here. आगे बढ़ते बेटा. Let's see what is written. A student uses a circuit containing an ammeter, a voltmeter, and a cell to take measurements to determine the resistance of a length of nichrome wire. अच्छा जी, ammeter, voltmeter and a cell use हो रहा है to determine the resistance of a length of nichrome wire. Define resistance. Resistance की definition बताओ. Potential difference per unit current. Potential difference per unit current. Simple. Draw a circuit to show the component should be connected. Use the symbol for resistor to represent the nichrome wire. आपने nichrome wire को represent करना है with a resistor. You have a cell like this. You connect an ammeter in series like this. Then you have a resistor like this. Then a voltmeter is connected in parallel like this. Simple. And you complete the circuit. This is how you do it. ammeter हमेशा सीरीज में, voltmeter हमेशा parallel में. Okay. The student measures the length diameter of the wire. Table 5.1 shows the measurement recorded for each quantity. अच्छा जी. Show that the resistance of the wire is this. How will you calculate resistance? Resistance is equals to voltage over current. Voltage की वैल्यू क्या है बेटा? 1.38. करंट की वैल्यू क्या है? 0.276. Can you calculate the resistance? 1.38 divided by 0.276. Yeah, this comes out to be 5 ohms. Exactly 5 ohms are you. Wow, very good. Let's further move ahead. Calculate to three significant figures the resistivity of nichrome. कैसे निकालेंगे? Resistance is equals to resistivity into length divided by area. Can you make resistivity the subject? Resistivity को आप subject बना सकते हो. Resistance into area divided by length is equals to your resistivity. Now, what is your resistance? 5. Area क्या है भाई? How will you calculate the area? Diameter is 0.496. Diameter क्या है? 0.496. How will you calculate area? Pi over 4, 0.496, 10 raised to the power of minus 3 का whole square. Beta, do you remember the formula of area? Pi d square over 4. Pi into diameter square divided by 4. I have done the same thing. Divided by the length. What is the length? 0.864. 0.864. Just plug and play into the calculator to calculate the resistivity. Plug and play into the calculator to calculate the resistivity. Resistivity comes out to be what? 1.12 10 is the power of minus 6. 1.12 10 is the power of minus 6 ohm meter is your resistivity. Okay, so now we have to calculate the percentage uncertainty in resistivity. बेटा resistivity में आपने percentage uncertainty निकालनी है. How will you do that? फर्स्ट एंड फॉरमोस्ट रेजिस्टिविटी का फॉर्मूला क्या था? रेजिस्टिविटी का फॉर्मूला यू हैव सीन हेयर, इट इज इक्वल टू रेजिस्टेंस इनटू एरिया डिवाइडेड बाय लेंथ। नाउ अगर आप फर्दर रियलाइज करो, रेजिस्टेंस आपको डायरेक्टली नहीं गिवन, यू आर नॉट गिवन द डायरेक्ट वैल्यू ऑफ रेजिस्टेंस, यू आर गिवन वोल्टेज ओवर करंट। तो रेजिस्टेंस की जगह वी कैन प्लेस वोल्टेज ओवर करंट। ऑल्सो यू आर नॉट गिवन द डायरेक्ट वैल्यू ऑफ एरिया, आपको डायमीटर गिवन है। इन प्लेस ऑफ एरिया वी विल राइट पाई डी स्क्वायर ओवर 4 divided by length. What does the formula of resistivity becomes? हाँ जी, रेजिस्टिविटी का फॉर्मूला क्या हो गया? पाई डी स्क्वायर कैपिटल वी डिवाइडेड बाय 4 IL. Now if you realize पाई एंड 4 आर कांस्टेंट, बेटा पाई और 4 कांस्टेंट है, तो परसेंटेज अनसर्टेनिटी इन रेजिस्टिविटी विल बी इक्वल टू व्हाट? 2 times the percentage uncertainty of D plus the percentage uncertainty in voltage plus the percentage uncertainty in current plus the percentage uncertainty in length. 2 times क्यों किया है हमने डायमीटर की परसेंटेज अनसर्टेनिटी को? बिकॉज डायमीटर इज स्क्वायर प्लस द परसेंटेज अनसर्टेनिटी ऑफ वोल्टेज प्लस द परसेंटेज अनसर्टेनिटी ऑफ करंट प्लस द परसेंटेज अनसर्टेनिटी ऑफ लेंथ. Now how will you calculate the percentage uncertainty in diameter? Diameter की absolute uncertainty is 0.002, actual value is 0.496. So write it here, 0.002 divided by 0.496 multiplied by 100 plus. How will you calculate voltage की percentage uncertainty? 0.02 divided by 1.38. Simple, 0.02. 1.38 multiplied by 100. How will you calculate the percentage uncertainty in current? 0.001 divided by 0.276. 0.001, 0.276 multiplied by 100. How will you calculate the percentage uncertainty in length? 0.001 divided by 0.864. 0.001, 0.864 multiplied by 100. Can you calculate the final answer of percentage uncertainty in resistivity? बेटा रेजिस्टिविटी के अंदर फाइनल परसेंटेज अनसर्टेनिटी निकाल सकते हो. लेट्स पुट इट हियर एज वेल. कैन यू सम अप दिस एंटायर थिंग? हाँ जी, परसेंटेज अनसर्टेनिटी इन रेजिस्टिविटी किसके इक्वल आ रही है? द परसेंटेज अनसर्टेनिटी इन रेजिस्टिविटी कम्स आउट टू बी व्हाट? 2.7%. सिंपल. नाउ यू हैव टू कैलकुलेट द एब्सोल्यूट अनसर्टेनिटी इन पी. कैसे निकालेंगे? You know the percentage uncertainty in resistivity, yes? अभी निकालिए 2.7. This can be replaced by what? Absolute uncertainty in resistivity divided by the actual value of resistivity multiplied by 100 is equals to 2.7. बेटा actual value of resistivity क्या आई है? 1.12 10 is the power of minus 6. 1.12 10 raised to the power of minus 6 into 100 is equals to 2.7. Can you calculate the absolute uncertainty in resistivity? Yes. 2.7, 1.12, 10 raised to the power of minus 6 divided by 100. Can you calculate the absolute uncertainty in resistivity? This comes out to be 3 into 10 raised to the power of minus 8. Simple. आगे बढ़ते बेटा. Let's see this. This looks easy. Figure 6.1 shows 4 alpha particles W, X, Y, and Z moving towards a gold nucleus that is in thin gold foil. Okay, this is a gold nucleus in thin gold foil. Okay, the paths of particle X and Z are shown. Okay, complete figure 6.1 to show the possible paths of W and Y. ओके, हाउ विल यू शो द पाथ ऑफ डब्ल्यू? बेटा डब्ल्यू बिल्कुल एक्स की तरह क्या करेगा? इफ यू रियलाइज डब्ल्यू is hitting the nucleus like this, almost hitting the nucleus. So it will get reflected like this. W का आपने पाथ क्या करना है? Just like X banana. You have to make the path of W just like X because both of them are hitting the nucleus. Okay. What about Y? Y will deflect like this. Simple. Now, explain what may be inferred about the structure of the atom from the path of particle X. बेटा particle X का path देख के आप क्या refer कर सकते हो from the structure of the particle? Nucleus is positively charged. Because if the nucleus is positively charged, then only it can reflect back alpha particles like this. ठीक है? You can say nucleus is positively charged. बेटा न्यूक्लियस पॉजिटिवली चार्ज होगा तभी इस तरह की रिपल्जन होगी, रिपेल बैक होगा. When a beam containing many alpha particles is incident on a thin gold foil, nearly all of the alpha particles follow the path similar to particle Z. अच्छा जी. Most of the alpha particles follow this path. They remain undeflected. बेटा most of the alpha particles undeflected रहते हैं. अब देखते हैं एग्जामिनर क्या पूछ रहे हैं. What may be inferred from this about the structure of an atom? इससे हमें क्या पता चल रहा है? Atom has large empty spaces and the size of nucleus is very small. So you can say atom has large empty spaces and the size of nucleus is very small. Simple. Let's further move ahead. आगे बढ़ते हैं. State the mass and charge in terms of atomic mass unit and elementary charge of an alpha particle. बेटा अल्फा पार्टिकल का मास और चार्ज क्या होगा? अल्फा पार्टिकल कंप्राइजेज टू प्रोटॉन्स, सो द चार्ज बिकम्स 2e. अल्फा पार्टिकल हैज अ मास नंबर ऑफ 4, तो मास क्या हो जाएगा? 4u. सिंपल. There are two types of hadrons, okay? The hadrons that are in alpha particle are composed of three quarks. State the name of this type of hadron. बेटा जो भी hadron जिसके पास 3 quarks होंगे are known as paron. देखो देर आर टू टाइप्स ऑफ हेड्रॉन्स. दो तरह के हेड्रॉन्स होते हैं. एक वो जिनमें 3 कॉर्क्स होते हैं, दे आर नोन एज पेरॉन. और एक वो हेड्रॉन होते हैं जिनमें 2 कॉर्क्स होते हैं, 1 कॉर्क एंड 1 एंटी कॉर्क, दे आर नोन एज मीजॉन. ओके. शो बाय रेफरेंस टू देयर constituent quarks that the hadrons in alpha particles have a charge of either 0 or +1. अच्छा जी. अल्फा पार्टिकल में जो हेड्रॉन है दे हैव अ चार्ज ऑफ आइदर +1 or 0. We have to show that. Now how will we show that? So wherever, ठीक है. Now first of all, if I make an alpha particle, can you realize it comprises of a proton and neutron? बेटा अल्फा पार्टिकल में दो ही तरह के हेड्रॉन है, प्रोटॉन एंड न्यूट्रॉन. What is the quark composition of proton? Up quark, down quark. What is the charge on one up quark? 2 over 3 E. What is the charge on one down quark? -1 over 3 E. Can you see +2 over 3 E plus 2 over 3 E -1 over 3 E? The charge on proton becomes +1 E. बेटा न्यूट्रॉन की कॉर्क कॉम्पोजिशन क्या होती है? अप डाउन डाउन. Up is 2 over 3, -1 over 3, -1 over 3, 0. So the two hadrons which alpha particle contains, proton and neutron. बेटा alpha particle में दो hadrons हैं, protons और neutrons. दोनों का charge either +1 है या 0 है. We have shown that through the quark composition. If you have any questions, you can ask right away in the chat.